Alright, welcome everyone to Spine Conference. Today's going to be an unusual spine conference. Usually this conference is held with about 15 to 20 orthopedic surgeons, radiology, physician assistants, physical therapists, nurses, administrators. We did have this conference on October 26th, but unfortunately it didn't work. The sound was off, so I'm going to repeat the conference with a special guest, my 10-year-old son.
Hi.
We're going to talk about MRI scans. Now, what are MRI scans? MRI scans are a way to look into the body. So what it does, it can cut slices of the body.
What does MRI stand for?
It stands for magnetic resonance imaging. We're going to go into that, okay? Magnetic resonance imaging. MRI. Magnetic resonance imaging. And you can take slices of people. Look at here. Here's a slice of a whole person. Isn't it unbelievable? You can see the insides. Amazing, right? And this is the arteries of the brain. And this is someone's brain. You can see the nose, the eyes, the mouth. And that's what you look like on the inside. That's what your brain looks like. Yeah, it's incredible, isn't it? You know what these are?
I think they're the, what was the word?
I think they're kidneys.
Kidneys, yes, kidneys.
I think so.
That's the word.
So, MRIs are, we're going to skip that. So, we as a country perform almost the most MRIs in the entire world. So if you look at, it's awesome, right? But it's expensive. For every 1,000 people, 91 people get an MRI in the United States per year.
That's a lot of people.
It is a lot of people. And it's more than Iceland, Luxembourg, France, Belgium, Canada, Denmark, Czech Republic, Australia. Do you think there's any country that does more MRIs than us? Can you think of a country that spends a lot of money? That's going bankrupt? What government? Greece.
Do they have
Greece is the only country that does more MRI scans than the United States. They do 97 per 10,000 people.
Wow.
They spend too much money, right? We spend a lot of money too on healthcare. So we're always worried if Greece tumbles and the banks, the government goes bankrupt, they're worried that Spain will go bankrupt, Italy, Portugal, Ireland.
That's not good.
It's not good. And we spend a lot of money on healthcare. Gross domestic product is all the money we spend in our country all year on everything. And 17% of every dollar that we spend, 17 cents of every dollar that we spend is on healthcare. That's a lot. We spend a lot of money on healthcare. And everybody gets MRI scans. You know who this guy is? What teams he play for?
Ravens.
He plays for the Ravens, right? This is Ladarius Webb, and he hurt his knee. And the minute a football player hurts his knee, what test do they get?
MRI.
They get an MRI the next day. And a lot of people think that anytime you have something that hurts, you have an injury, you get an MRI right away, because that's what the football players get. And MRIs are expensive. So almost 1 in 10 people get an MRI every year in the United States. That's incredible. It's like 9%. So how many MRIs do we do a year? About, if you use those numbers, 27 million MRIs. And each MRI costs about $700 bucks, $600 for the MRI itself.
That's a lot of money.
It's $19 billion. That's a lot of money. And I spoke at Upper Chesapeake at my hospital. I spoke with Karen, and she runs the MRIs, and she said they do about 25 scans during the day, every day, Monday through Friday. And then on Saturdays and Sundays they do maybe 12. And there's 7 holidays a year. So each year they do about 7,650 MRIs, which comes out to about $5 million a year at our hospital.
That's a lot of money.
It's a lot of money. So you wonder, how much is that money? How many dollars? So if you take $100 bills, it's 2/3 of an inch. If you take a stack of $1 bills, that's 100 of them, it's 2/3 of an inch. Not that big, right? $1,000 is a stack 4 inches tall. So if you take $1 bills, it's 4 inches tall. Now, if you stacked $1 million, how tall would it be?
133 feet tall.
Yeah, $1 million is 330 feet tall.
Wow.
You know what's 300 feet tall? What's that? What is that?
What was it? Oh yeah, Millennium Force.
Yeah, Millennium Force. So if you stacked $1 bills all the way to the top of Millennium Force in a big stack, that's $1 million.
Wow.
Okay,
That's a lot.
how tall is $1 billion? That's a million. How tall is $1 billion? $1 billion is 1,000 million. How tall is $1 billion? Would you guess?
1,000 times taller than Millennium Force.
Yeah, how tall? Like tallest building? What do you think?
I think it's probably is. I don't know.
I'll show you how tall $1 billion is. Remember this guy, Felix Baumgartner? He jumped 24 miles high, the highest jump ever, parachute jump. It's 3 times higher than that, 63 miles tall. That's how tall $1 billion.
That's a lot of money.
It's a ton of money. That's $1 billion, and we spend $19 billion a year. Now, how tall is $1 trillion?
Oh.
A trillion is...
To the moon.
Huh?
To the moon.
Exactly. $4 trillion goes all the way to the moon,
Oh.
which is 230,000 miles.
That's a lot of money.
$4 trillion is how much Obama added to our national debt. So we had to borrow money.
This is politics now?
Yeah, we're going into politics though, but I know, I'm sorry. Okay, now who's this guy? Who's this old guy with a beard?
Papu?
No, he's not Papu. This is Ronkin. And what you know what he discovered? What's the thing on the right?
X-rays.
X-rays. He discovered X-rays.
Oh, cool. It shows his
Yeah, he was German. Whose X-ray was that, do you think?
His own?
His wife's. His wife's, you're right. That was the first X-ray ever taken.
Wow.
His wife's hand. And he was German, and he had very high ideals, and he was very honest. In high school, they asked him, one of his friends drew a picture of the teacher that was a bad picture, and the principal said, you have to tell us who drew the picture. You have to tell us which friend drew the picture. And Ronkin would not tell on his friend, and they expelled him from high school for that. But he held to his ideals. He would not tell on his friends.
Wow.
Pretty impressive, right?
Uh-huh.
So this is an MRI scan. So that's the patient, and they go into like this machine, this circular machine that looks like a big donut sort of, and it has magnets and coils and things that picks things up. So you sit on this table.
Is there even chocolate?
And it, what? Chocolate.
Never mind.
And it rolls into the tube, and it takes the
Awesome.
picture.
I want one of those.
You want an MRI?
Yeah.
They cost like $2 million.
No, I mean, I want.
Or you want to get a test?
I wish I had one. That would be so cool.
Now they're made of magnets. What is that? What are you looking at?
Magnets.
That's a magnet. You know what a magnet is? Mm-hmm. Now, where does the word magnet come from?
Greece.
You knew that?
Yeah, I researched the first person, the father of science. His name was Thales, and he studied magnetism.
You studied magnetism?
Uh-huh.
Wow.
Well, he thought that when you rub two things together instead of electricity, he thought that was magnetism.
Oh,
So
interesting.
I always think that's where it came from because.
Well, you're close. Look, this is where it came from. This part of Greece right here. Look, I've never been there. It's kind of
Starts
like
with an M.
yeah, magnesia. It's
Yes,
called magnesia.
That's where he was from. That makes sense.
Really? Wow, I didn't know that. This is where
I forgot his name.
this is where the word magnet comes from Magnesia, Greece,
That makes sense.
and it's because they have a certain rock there called lodestone, and this lodestone rock is a naturally made magnet.
Awesome.
Yeah, it's a magnet that's found in nature.
Wish I had one of those.
Do you want a lodestone?
Compass.
Yeah, so what did the ancient people do? They used to take a tiny bit of lodestone, they'd put it on a metal stick, and they would use it as a compass so that they can sail in ships. Because in the middle of the ocean, you don't know where you're going.
Good point.
So they used the compasses to know where they're going. So that's where magnet comes. Now, what's a magnet?
Magnet, it draws metal objects closer to it, and it has something to do about the. I know something about compasses.
Okay,
I'm
well,
not
you're
sure
right.
about
You're right.
magnets.
It's two metals that have an attraction for each other. And now I'm not an expert on this, but from my understanding, it has to do with atoms. Mm-hmm. So atoms. This is an atom. See it? Mm-hmm. An atom. Yeah, it's physics. An atom. In the middle of it, there's a nucleus, which has a positive charge, and then there's an electron, which is a negative charge. And the electron runs around in orbit around the nucleus like crazy, like 1,000,000 miles an hour. You can't see it. That's the electron. It runs around like in circles all around the nucleus, and that makes up an atom.
What is that?
Now this is the magnetism. It has to do with how the electrons are aligned with each other. So the Earth has its own magnetism, and we measure it with something called Tesla. That's like the unit of measurement that we give. You know, like an inch or like a foot or like a gallon. In magnetism, it's called Tesla. That's how we measure how strong it is. So the Earth magnetism, right now, you have Earth magnetism on top of you.
Oh.
It's flowing through you, and it's about 25 microtesla, which is like a thousandth of a Tesla. So it's really small. And the Earth has its own magnetism. Now, MRIs come from something called nuclear magnetic resonance. That's where it started. And do you know who these guys are? I don't know who they are either, so don't worry about it. Their names are Bloch and Purcell, and they're from Stanford and Harvard. And they invented nuclear magnetic resonance in 1946. That's a long time ago, right?
Uh-huh.
Papu was like 13 years old when they invented this. And it has to do with atoms. So normally atoms are not lined up. They're just, everybody's like looking different directions. Like one guy's spinning this way, another guy's spinning this way, another guy's spinning this way, another guy's spinning this way. What you do with an MRI scan is you put a magnetic field on a bunch of atoms, and they all line up in one direction. And then you slap it at 90 degrees with a radio force. A radio is a type of radio frequency. It's a type of energy. And then when you hit it with a force, they all spin a little bit, and when they spin, they give off energy. And you capture that energy and look at it, and that's what nuclear magnetic resonance is. So let me show you. So if you have this pure chemical compound in a cup, and then you put magnetism on it, all the atoms line up, and then you hit it at 90 degrees with a radio. You know what a radio is, right?
Yeah.
You hear music on the radio?
Uh-huh.
You hit it with radio, and then it changes the atoms and it gives off energy, and you capture it. It looks like this. And you can read this and you can say, oh, this is this compound. It has a characteristic. It's like kind of like a picture. It tells you what it is. So let me show you. Radio is right here. It has the lowest force of all the energies. What's this one?
Microwave.
Yeah, what's a microwave? You can put your hot dog in a microwave, right?
Yeah, I think it gives nuclear stuff.
Yeah, microwave's a little bit stronger. There's infrared. What's visible light?
We have right now.
Right, the sun. So
Then
that has
there's
energy too.
Ultraviolet, X-ray,
right.
Then there's a gamma ray.
Gamma ray is the highest.
Yeah. You don't want to mess
The
with
high.
that.
You don't want to mess with that. It's really powerful. Okay, are you totally bored yet?
No.
No? Okay. You're a pretty good student.
Ooh, the periodic table. Now we're going into science.
Yeah, what's the periodic table?
It names all the elements.
All the elements. These are all the different types of atoms.
Has the least amount of atoms.
Wait a minute here. Helium is number 2. What's number 1?
Oh.
What is it?
Hydrogen.
Hydrogen's the lowest. Hydrogen's 1.
I get mixed up between the two.
There's all sorts of. What's your favorite element?
I like uranium.
Uranium. Why?
I don't know.
Make atom bombs? You want to make an atom bomb?
No,
Here it is,
I
right
like-
here. Uranium's number 92, right there.
Because it's
I like number
pretty cool
93.
because it emits its own energy. It emits its own energy.
What about neptunium? Like 93, because that's Salodinata's number.
Good point.
I'm just kidding. All right. So what?
Neptunium's not my second favorite. It's cool.
What are we made up of, human beings? Right here, look.
Calcium.
No, we're made up mostly of
no,
oxygen.
That's Earth crust.
That's Earth crust. No, this is what a human
Oxygen.
body.
Oh, yeah,
Oxygen,
hydrogen,
carbon, hydrogen, and other.
What's the other?
Oh, there's like a bunch of stuff.
Really?
We won't go. This is where all the water is in the world. Do you want to know where all the water is in the world?
Okay.
Most of the water in the world are in the oceans, 96%. And then the fresh water, it only makes up 2.5%. And then of all the fresh water, most of it's in the ice caps and glaciers. But we know this is getting melted right now because of global warming. And 30% is in groundwater. And the surface water, which is like rivers and stuff that we drink, that's only 1% of the fresh water. And then out of the surface water, most of it's ice and snow, and the rest is in lakes.
That's not a lot of water.
No.
Compared to the rest.
No. Now these are our body parts and how much water is in our body parts. So which body part has the lowest amount of water?
Teeth.
Teeth, yeah, because they're hard as a rock, aren't they?
Uh-huh.
And what has the most water?
The brain?
Brain's got a lot of water, doesn't it? It's incredible.
Wow. Probably really mushy.
So where in our bodies, where is the water? Most of the water are in the cells. And then the rest is in the interstitial, which is like between the cells and the blood. And the lowest amount is in plasma, or in the inner side of our blood. Now, what does NMR or MRIs, what do they use to look at the body? They have to have an odd number of protons. And we know that we're made up mostly of water. So what element should we study? It's an odd number that's made up of water. What can we study? Hydrogen.
Hydrogen.
So most MRI scans are based on hydrogen because it's got to be an odd number. And we're full of water. Okay, so this is the guy that invented... Huh?
Wait, that Albert Einstein?
No, it's not Albert Einstein. It's Raymond Damadian.
He looks like Albert Einstein.
He looks a little bit... Yeah, he does look like Einstein. He invented the MRI in 1971. He made an MRI and he first designed it to find cancer in the body, to find cancer cells. And then two other guys refined the process so that they changed it a little bit and they added some math to it so that they look at the body, look at normal bodies, not just find cancer cells, but just look at the whole body. And the first thing they imaged was a mouse. Now that's an MRI of a mouse right there. Do you see the insides of a mouse?
Yeah.
Can you see it? This is the liver here. This is the stomach. These are the lungs. They have tiny little lungs, don't they?
Yeah.
But their MRI was really old. See? Look, this is the first MRI of a mouse. It's not a very good picture, is it? It's very blurry. And these are the lungs right there. See them?
Yeah, but where's its head?
Well, it's a slice. So you don't see, you just see a slice through the middle. So to do an MRI, you need a really big, strong magnet and a coil.
Magnet.
Yeah, it's a really powerful, strong magnet. So this is a case, and I'm going to show you how the MRI helps me in the case.
Okay.
This is an 82-year-old woman. How old is that?
About Papu's age.
Papu's age, yeah. And she has really bad back pain.
Ouch.
And she fell, and it hurt super bad. And she went to the emergency room. She was reaching in the closet to get some clothes, and she fell down. And she had terrible pain. She couldn't walk. She went to the emergency room. She injured herself on September 16th. She has a history of a fracture long ago, problem with her heart. She had something taken out of her breast, but it wasn't cancer, and high blood pressure, and she lives by herself. Now, this is a side view of her spine. Come here, take a look at it for me.
Is this a riddle?
A little bit, yeah. This bone here, the spine's made up of a bunch of bones. They're like cubes, all stacked on top of each other. This one's normal. See how it looks like a square?
Yeah, and then I can see it.
Where?
Right,
Point to something that's wrong.
right there.
That one, yeah. How's that different?
Looks uneven.
Looks uneven, right? How about this one?
Broken. I think it's a little uneven.
It's a little uneven. How about this one?
Still uneven.
How about this one?
I can't see that one that well.
You can't see very well, right? How about this one?
That one? Uneven.
A little bit uneven. So it's hard to. So a lot of them are uneven. So maybe
Looks
a lot.
Like I got order.
So if they all look abnormal, which one's broken now?
They all look.
You can't tell, right?
Yeah.
You don't know which one's the broken one. It should be a square. Here's a front view. Okay, this is a CAT scan. Now, a CAT scan shows bones too. A CAT doesn't stand for CAT like meow. A CAT stands for CT, which is computer tomography, which is basically a bunch of x-rays all lined up together, and it shows the bones in the body. So you can see these squares are totally square, and this one's not, right? This one's a little crooked, this one's crooked. Now look at this bone. See how that crack going all the way through? That's the one that's really broken. But sometimes you can't tell. You don't know if this one's broken too. This one could be broken. So the CAT scan just shows the shape of the bones, but it doesn't give you more information than that. But the MRI does. Let me show you. This is the CAT scan. Now look at the MRI now. The MRI lights the water up. So this is the water in the spinal canal. You have fluid in your spinal canal. And these, remember the crooked bone we saw in the CAT scan? See how that bone looks all the same? The same color all throughout the bone. But see how the color here is irregular?
Yeah.
And it's different shades. This one's the broken one. So with the MRI scan, you can see the inside of the bone. Well, know which one's broken. So in this person, you can say, hey, these broke a long time ago, but now they're okay. They're healed. They're still crooked because they got crunched a little bit, but then they healed up. But this is the new one. This one broke, and this is the one that hurts. You can tell that on the MRI scan. See that?
Yeah.
So without the MRI, you can't really tell. See the cross again? That's where the break is. Can you point it out? You see it?
Yeah.
Yeah. Which one lights up the most? Which square lights up the most that's broken? Yeah, that one. See? It still lights up. So you can really tell with the MRI. This one lights the, this is called fat suppression. And it's a good one. It's T1, it's T2 weighted fat suppression. So this one is really good for fractures. This is hold on. This is T2 weighted, lights up the water. And this is T1 weighted, it lights up fat. So here's the fat next to the skin. This is the woman's buttocks. This is the fat.
Yeah.
Did I say a bad word?
No.
So there's T1 weighted images and T2. T2, I remember T2. You remember T2? It lights up water. Do you know how you describe water in the formula? H2O.
Yeah, I know.
So remember, H2O is water. So T2 lights up water, and the other one lights up fat. So that's how you can remember it. T2 weighted MRIs. So this is what happened. This patient had terrible pain. She couldn't walk. So I had to do something. I wanted to do something for her, and I stuck cement into her broken bone to help her with her pain. And this is the X-ray in the operating room. Can you see? Can you see the squares?
Barely.
Yeah, just barely. Sometimes it can be very difficult. I had a hard time seeing it too, but eventually I could see just enough. And there I inserted cement into the bone that helped her with her pain. And here's a front view. And here's a side view.
I like the front view.
You like the front view better? And the cement hardens immediately and gives the people immediate pain. Not everybody needs this, but the people, if they have terrible pain and they can't walk, that's when we stick cement in them. We give it a little time, see if they get better on their own. But if they don't, we do the cement procedure. It's a little bit dangerous, not really though. So there's CAT scans and the MRI. CAT scans, remember the X-ray ones, they're faster, they're cheaper, they're only like $200. They're quicker, that you don't have to stay still for them. It's not really a tube, it's a big tube in the CAT scan. You can see bones better. MRIs are better because there's no radiation, there's no X-rays, it's just magnets. MRIs you can see better, and you can look into the body better. And there's no X-rays. Other things you can find better here's an X-ray of a knee, and here's an MRI of a knee. Can you see the broken part of the bone?
Yeah.
Where? Show me where.
Right.
Yeah, that little break there. And this is where the child. This is a child's knee. It's like a 10-year-old. That's okay. This is where the child grows. This is called the growth plate, and he broke it right there, and you can see it really well on the MRI. Yeah. Another thing you can see well. This is a side view of a foot. You can see this where the bone dies sometimes. It's called avascular necrosis.
Bones can die?
Bones can die, yeah. Avascular necrosis. Okay, this was the mystery case. This was a mystery case I showed the radiologist. It was an 87-year-old woman who had previous surgery, and she couldn't walk. And this is a side view X-ray, and it's really like deformed, isn't it? Yeah. And the bones are deformed. They're weird looking. And the discs are right here. They're really weird discs. And on the T2 weighted image, which lights up the fluid, the discs lit up here. And I had no idea why the discs lit up. I had my theories, but I know. I asked everybody. Was it an infection?
Maybe they filled up with liquid.
That's what I think. Somehow it filled up with liquid. I don't know how, but somehow fluid got in there. Because there was nothing else wrong with her spine. So I asked my friend, the radiologist. He wasn't sure either. But my theory is that just for some weird reason it filled up with liquid. Maybe somebody out there in the world could understand this process better, and they can email me and tell me what it is. Here's the X-rays. There's maybe a vacuum sign. And the MRI, it lights up with fluid. The discs do. Here's a axial cut. Okay, who are you voting for in the elections?
I'm not.
You're not sure?
I might be voting for Mitt Romney.
Why?
I'm not sure.
You're not sure.
It's kind of even. No.
Okay. Well, that's it. Thank you for your attention today. Do you have any other comments or questions about MRIs?
No.
No?
Yeah.
Okay, good job.